Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 asks, what is the Lewis structure, hybridization, and geometry of phosphorus pentachloride, PCl5? Okay, so we first need to draw out the Lewis structure for phosphorus pentachloride. And the first step in doing so is to find the total number of valence electrons in this molecule. So phosphorus has 5 valence electrons, and chlorine has 7. And since we have 5 chlorine atoms in this molecule, we multiply this by 5. So in total, we have 40 valence electrons. So now let's try to draw a skeletal structure for this molecule. In this case, our phosphorus is most likely to be our central atom because it is less electronegative than the chlorine atom, and also it's able to form multiple bonds. So since chlorine only needs the one electron to fill its valence shell, it's unlikely for it to be the one to form multiple bonds. So let's draw 5 bonds to the chlorine. And we can also draw in all of the lone pairs on chlorine as well. Okay, so if we count how many electrons I've drawn so far in this structure, and we recall that each bond contains 2 bonding electrons, and each of the chlorine atoms has 6 electrons in the form of lone pairs, then we can see that I already have my 40 electrons in this structure. So now we can analyze it further to find out its hybridization and geometry. Okay, so if we look at our central phosphorus atom, we'll see that there are 0 lone pairs, and it is bonded to 5 atoms. So we can say 5 bonded atoms. And by using a Vesper theory table, we can determine its hybridization, molecular shape, and electron geometry. So let's see here. It might be on the next page. When we have 0 lone pairs and 5 bonded atoms, we have a trigonal bipyramid molecular shape and electron geometry. So typically when the central atom doesn't have any lone pairs, it has the same molecular shape and electron geometry. So like in our case, are both trigonal bipyramid. and its hybridization is sp3d. Okay, so there's another method that we can use to find out the hybridization. So one is to count how many charge clouds the central atom has. Okay, so I'll define what a charge cloud is, but basically it's either a lone pair or a bonded atom and if we have the 5 charge clouds like we do in our structure, then it is considered sp3d. If we only had 4, then we'd know it's sp3. 3 is sp2, and 2 charge clouds is sp hybridized. So this is another way we can find out the hybridization. Okay, so let's see what the junior tutor said. They said to determine the total number of valence electrons for the molecule in their outermost shells, phosphorus and chlorine have 5 and 7 valence electrons respectively. So they also got 40 in total. They drew the skeletal structure by connecting the 5 chlorine atoms with a single bond and then placed the remaining valence electrons as lone pairs, and they got the same final Lewis structure. A simple way to determine hybridization is to count the number of atoms and the number of lone pairs attached to it. So they refer to this as the hybridization number. It can also be known as charge clouds or even like domains. And they summed up hybridization as well. And looking at the Lewis structure, there are 5 chlorine atoms attached with no lone pairs. So the molecular geometry is trigonal bipyramid. So this solution is correct.